Hello and welcome to another one of these ADD videos. Today we're going to be discussing the topic of inverses. What is an inverse? Well, in order for a function to have an inverse, it must be one-to-one. What does it mean to be one-to-one? Well, for every y, there's only one x, right? This can be depicted by looking at the horizontal line test. And that's basically if you pass a horizontal line up and down your graph, you should only be touching your function with the horizontal line at one time only. All right? So let's see that in action. Here's the function. Notice that I had to look at a restricted domain. If I had the entire parabola of x squared, it would no longer be one-to-one. Right now, if we do the horizontal line test, here's my horizontal line. I can run it up and down. You see that I only touch my function at one point, and only one point, so it's one-to-one. Now, if I had the other half of the parabola right here, it'd be touching at 2 points and would not be one-to-one and would not have an inverse, okay? By restricting the domain as I did here, then it does have an inverse. So, how do you find these inverses? Graphically, I can find the inverse by reflecting about the line y equals x. So wherever it's close to the axis, I'll be close, get further away, come back and do one of these numbers, and it should look something like this. And if you were to solve for the inverse, you'd see that it was the square root of x. All right? So reflected about the line y equals x. So again, if it's one-to-one, it has an inverse. How do you find the inverse? Well, what you're going to do is you're going to switch the x and the y in your equation and then solve for y. If you see f of x, you can replace that with a y. They're synonymous. So y equals x squared. So you would switch these two and get x equals y squared, square root both sides to get that. Okay, and we're only looking at the positive half. Now, how can I prove that it's in inverse? Well, if I do the composite, either way, plug this into there or this into there, everything should simplify down to x when you simplify. Just to prove that that is indeed the case, let's see it in action with this basic one. When we do the composite function here, f of f inverse or f inverse of f, you get x. All right? So that's basically the concept. Enough for you to just get started, switch x and y, solve for y, make sure the function's one-to-one. Okay, if there's more than one x for each y, then it won't have an inverse. That's basically it. So practice, practice, practice as always. Hope I've helped you understand the basics enough for you to try the problems. Thanks for watching and have a great day.